Reality is merely an illusion, albeit a very persistent one. Albert Einstein. A spy presses a button on their suit and disappears. A wizard pulls on a cloak, vanishing limb by limb. A star pilot flicks a switch, and their ship fades into the vastness of space. Invisibility has always been one of the most captivating powers in fiction, appearing in countless stories. But could this fantasy ever become a reality? Invisibility is a relative concept. Researchers and engineers working in stealth technology have developed planes that are almost undetectable to radar. They've even designed cloaks that can hide tanks from thermal cameras. However, these innovations don't make objects invisible to the human eye. Our eyes detect visible light waves that reflect off objects. To make something invisible without turning off the lights, we would need to see the light coming from behind the object, instead of the light bouncing off of it. This requires controlling how visible light waves behave. One method to achieve this is through reflection. It's a predictable approach, but it requires maintaining precise angles. This is challenging, especially for moving objects. Another technique involves absorbing light using ultra-black materials made from light-capturing nanotubes. But painting something black doesn't make it truly invisible. Instead, many researchers focus on bending light around objects using refraction. Refraction happens when light changes direction as it passes through materials with different densities. For example, think of how a person's legs appear distorted when submerged in water. Since water is denser than air, the light bends as it moves between the two. In nature, refraction has its limits. Even in materials with the highest natural refractive indexes, light can only bend so much. But in labs, scientists have found ways to surpass these limits. In the 1990s, theoretical physicist John Pendry worked with a defense lab to find ways to absorb radar signals. The result was a mesh of carbon fibers, so thin and densely woven that it interacted with light differently than regular carbon. This discovery inspired Pendry to experiment further. By modifying materials at the microscopic level, he created tiny structures capable of bending light in ways previously thought impossible. He called these structures metamaterials. His most famous creation, the split-ring resonator, allowed light to bend beyond what was once considered possible. This discovery of negative refraction sparked a new era of invisibility research. Today, scientists have designed metamaterials that can completely redirect microwaves. But creating a true invisibility cloak requires bending all wavelengths of visible light at the same time without causing distortion. This is difficult because refraction affects different wavelengths differently. That's why prisms create rainbows, separating light into various colors. Despite their potential, metamaterials aren't the only path to invisibility. One lab managed to create a controlled desert mirage using hot air to bend light. This effect can create visual distortions that make objects seem invisible. However, it requires extremely high temperatures, which aren't practical for everyday use. Another team designed a configuration of glass lenses that can bend light around objects within a ring-shaped area. In theory, this setup could hide a person, but it only works if both the observer and the hidden object are perfectly aligned. Some researchers have tried using cameras and projectors to record the background and display it on a cloak. While promising, this approach faces challenges like lag and color distortion, making it less effective. While true invisibility remains elusive, these experiments show how close science is to making the impossible possible. If there's one thing we've learned from history, it's that today's limitations could disappear tomorrow. For more videos, please like and subscribe.